In this video, I examine various chart types that are offered by Microsoft Excel, and I evaluate or assess how effective they are as good data visualizations. This video is a follow-up and is based on a prior video, which looks at the components of good data visualizations. If you haven't watched that yet, be sure to look at that so that you understand the bases and the principles on which I evaluate Microsoft Excel. Now, the charts I'm looking at are those that are available in Microsoft Excel as of 2022 in the latest Office 365 version. To find them from Microsoft Excel, you would go to the Insert tab, and there's a chart section. You can click on various charts here, but to see all of the charts at one point, you can click on this little button here to see all charts. And first offers some recommended charts based on the data you might have on the screen. But if you click on the All Charts tab, it goes through a list of all the charts that are offered automatically by Microsoft Excel. And these are the ones that I'm not going to evaluate all of these, but I'm going to evaluate most of these, and based on principles of good data visualization. So first, looking at the column chart and bar chart, which are basically the same things. Column charts are vertical and bar charts are horizontal. The bars and columns are some of the most effective tools for data visualization and are highly recommended. However, when they are stacked, that is, the various subcategories are stacked in single columns, sometimes they're effective if the quantitative measure that they're being compared to are actual amounts, but if they are percentages where they all add up to 100%, then they're not very effective. Because usually, in this little example, you can tell which ones are bigger, but a lot of times the different segments, different categories are very close, and it's hard to distinguish based on the area size which ones are really larger. 3D graphs are all around a bad idea when displayed on a 2D surface, because this is a 2D screen or it's printed out in 2D. So 3D graphs just do not work effectively. They obscure information because they expect us to be able to measure depth, and humans don't do that very effectively when projected on a 2D surface, at least not precisely. So all these 3D versions are pretty poor expressions. And again, when they're stacked, it's hard to distinguish the areas. Next, you have the line charts. And there's various kinds of line charts that are offered in Microsoft Excel. Some line charts are individual series, some are stacked to 100%, some have dots, and you even have 3D surface maps. So based on my prior comments, you can probably start to get an idea. The line charts are very good choices, and whether they have dots connecting the points or not, because they show a sequence. They show a sequence of things that are in some progression, whether time or some other logical sequence. However, when you stack the values of the line charts, it has the same problems of stacked column charts or bar charts, and that is that it's very hard to tell what the totals are and what the individual differences of each value is. And when it's set to 100%, it's even worse. And whether you add dots or not, that's not effective. And comparing lines in 3D adds a level of depth that humans cannot effectively perceive accurately on a 2D surface. Now, just one note about 3D. I emphasize that the problem with 3D is 3D displayed on a 2D surface. If you have a computer visualization where you can actually interact with a graph so that you can rotate the 3D, then it's fantastic. It's a hugely fantastic source. But I'm talking about when you only have a 2D surface and you're trying to pretend it's 3D. That does not work. Another family of charts are scatter charts and bubble charts. And these present dots on a two-dimensional surface, sometimes connected with lines. Bubble charts adds a third dimension where the size of the dots indicates some additional value. So when scatter plots or scatter charts are very good examples, or very good chart types, because the location of the points on two axes represents something meaningful. These variations that connect the points by lines, if there is a sequence going on, that is helpful. That's effectively a type of line chart. But when you have large data sets, and I mean, not even very large, even from 10 to 15 to 20 and anything higher, they just become a mess. So connecting scatter plots only works for very small data sets. And so it just depends on the size of data set, whether it's useful or not, but usually it does not work well. Bubble charts are valuable in that you can encode a third quantitative or numeric variable, but they only work if the differences between the bubbles are quite large. People cannot effectively perceive slight differences between the bubbles. Such as these two black dots are very large. There's a large difference between them. The two blue dots, not so large. It's not. You have to look a little bit carefully to know that the one on the left is larger than the one on the right, and that's the challenge with bubble charts. However, when you add 3D to it, it adds nothing except obscuring the relative sizes, and it's just not recommended at all. Another family of charts are histograms, Pareto charts, and box plots. And these are all specialized charts that are highly recommended for the purposes. Histograms are great for displaying the distribution of single variables. Pareto charts are one of the rare cases where you superimpose two chart types in a very effective way. It has a sorted column chart, cumulative column chart, and a line chart, which is a frequency polygon, which can a cumulative frequency polygon, which displays information in very effective ways. Box charts use one of the key effective, box plots use one of the key effective components of displaying distributions and displaying multiple distributions in a very small amount of space in a very meaningful and intuitive way. Then another type of charts in Excel is the map, where there's a geographic representation. So the layout is a geographic map and data is encoded there. This is a very excellent way of representing information if there's geographic information maintained. It's much more effective because people understand maps, especially if countries and regions they're familiar with, and putting the data on that is an effective way of communicating information that is geographic. So then here are some more. There's a family of pie and sunburst charts, which use a radial axis. So instead of an XY axis, the axis goes around in a circle, and it might be in 3D. Sunburst charts or donut charts is a variation where instead of a complete circle, it's a donut. Sunburst charts shows hierarchical information in a similar fashion. And these are all bad for the same reason, and that is that people cannot effectively tell the differences between angles. In all of these sample pictures, the differences are very clear. White is much bigger than blue, so that works. But once you add 3 or 4 or 5 categories, which most pie charts have, you have a lot of categories that are very close to each other, and people cannot effectively tell the differences between such close angles. And for that reason, none of these works. and they're even worse when you add 3D to the effect. Area charts and tree maps they use not only X or Y axes, but they also use the area sizes, relative sizes of areas to encode information, where larger areas encode important information. And these fail for similar reasons to pie charts. Uh, People not only have difficulty perceiving differences in angles, but they also have difficulty perceiving differences in areas. In this first one, it's obvious white is much larger or well, actually, these are superimposed, so it's not so obvious. It's the blue is not just what blue is. Blue is white plus blue. Here it's stacked. It's very hard to tell which is larger, white or blue. And then when you do to 100%, it's worse. 3D just distorts the relative proportions in even a worse way. Tree maps are very similar to sunburst charts in trying to portray hierarchical information by relative area sizes. But again, when area sizes are very close, it's very hard for people to tell the differences. Like it's not so clear, it's not immediately clear which of the blue squares is bigger, and nor is it clear which of these two upper right white rectangles is larger. When values are close, people cannot effectively tell the differences. Chart is a specialized type of chart, and unfortunately, I don't have the time to go into the details here. But it is similar to a map in that it shows different ranges of values in different colors, or it might show demarcations between lines on a 2D axis and sometimes in 3D. Because of its specialized nature and the way it shows data, surface charts are quite useful for the kind of data for which they're appropriate. Now, when they're expressed in 3D, there's a question mark there. This is one of the rare cases where 3D actually does kind of work a little bit, even if it's on a 2D surface, but it is still difficult to perceive the depth. And so I have a question mark there, and yet I won't totally write it off because of the unique nature of surface charts. Radar charts are a case where charts are shown around a circle and different values radiate from the center in a radial axis. And they might have points which are connected or not with different dimensions showing different values. Radar charts, they look impressive, but they're really hard to understand and follow. And just about anything you can do with a radar chart, it can be far more easily expressed with a standard column chart and can be more easily understood. That's because the lengths spread out radially are simply not easy to compare. Funnel plots and waterfall charts and some other specialized types. Funnel plots seem to be popular in marketing, where they show different elements sorted in decreasing order in a direction, and waterfall charts show one element and show the different values relative in height in a kind of a waterfall direction. Generally speaking, these are a bad idea. They look innovative, they look interesting, but they're not very communicative. A funnel plot is basically a horizontal bar plot with no zero axis. It looks impressive, but it actually obscures information. It adds nothing that a well-designed bar chart would not show. And waterfall charts are usually a bad idea. Again, they obscure information. The one exception would be if the x-axis represents time, and the differences in heights on each element, in time or a sequence, actually represent a progression in time when some value is reducing or increasing, then that would be useful. Unfortunately, a lot of times it's not used in that case and so waterfall charts often do not work. The last category that I comment on are combo charts, which is where one or more types of charts are combined in the same axis, the same X or Y axis, and are overlaid on each other. And they might either share an axis or each one, like here, the columns have one axis and the line has another axis, and these might be stacked, and there's opportunities to customize them. Um, if there is one axis for the for both types or the multiple types of charts, then that works very well. But when there's more than one axis, it usually confuses the reader uh, as to which axis applies to the other, and the fact that increases in one might not correspond to the proportional increases in another. It can be really used to contort information. So generally not a good idea to mix axes. A notable exception is a Pareto chart, which is one case where it works well. Then when you stack it and you're using area, in short, if one of the base charts is a poor quality chart to begin with or an ineffective chart, combining them doesn't help anything. And customizing charts, adding multiple charts is generally not that advisable. It's usually better to separate the graphs, to use more than one graph to tell different parts of your story rather than putting everything in one place, which rarely works, though there are some exceptions. So that's these are my recommendations for using graphs that you can readily find in Microsoft Excel. And of course, these are opinions. People have different preferences, have various perspectives on this. But again, if you watched the previous video on the principles of the components of good visualizations, you can better understand the reasonings behind these based on human perception of visual information.